So, have you ever used a chatbot, maybe something like ChatGPT, to draft an email or brainstorm an idea?
Yeah, most people probably have by now.
It's pretty amazing, right? But what if AI could go like way beyond just generating text?
Hmm.
What if it could actually do complex stuff for you, autonomously, start to finish?
Ah, okay, I see where you're going.
Yeah. For me, just imagining an AI handling all the messy details for a big project, stuff that takes me hours of back and forth, well, that's incredibly exciting.
That's exactly the transformation we're diving into today. We're looking at something called agentic AI,
Agentic AI.
and specifically its life cycle for enterprise processes. This isn't just AI that chats, it's AI that acts. It goes past generating text to actually executing complex, multi-step tasks out there in the real world.
Okay, so our mission for this deep dive is basically to give you a shortcut, right? To understanding this whole new paradigm.
That's the plan.
We're using insights from Debmalya Biswas's article, Agentic AI Lifecycle for Enterprise Processes. Really fascinating stuff.
It really is.
So we'll break down what agentic AI actually is, how you build it, how you govern it, which sounds important,
Oh, it is. Crucial.
and where it's already making a difference, like right now in businesses. So let's unpack this.
Okay, so maybe the best place to start is drawing a clear line. Most people know about LLMs, right? Large language models.
Like ChatGPT.
Exactly. They're mostly generative AI,
Yeah.
built to create text, have conversations. An AI agent, though, it's designed with a broader goal
Mm-hmm.
to execute complex tasks autonomously.
And complex tasks means what exactly? Give me some examples.
Sure. This article mentions things like making a sale, planning a whole trip,
A whole trip. Wow.
or booking a flight, arranging for a contractor to fix something at your house, even ordering a pizza.
Yeah, ordering a pizza feels a bit less complex, but I see the point. It's about taking action.
It is. And the range is huge. It really gets you thinking about all the possibilities.
This sounds a lot like that vision Bill Gates talked about.
It aligns perfectly, yeah.
Yeah.
He described an AI agent that understands natural language and just gets stuff done. Multiple tasks.
And his example was trip planning too, wasn't it?
That's right. Instead of you digging through websites, booking hotels, flights, restaurants, the agent uses what it knows about your preferences and just does it, books it, buys it, all for you.
That would save so much time. Now, when you dig into this, there's this core idea called the agentification principle. What's that about?
Right. Agentification. The core idea is pretty bold. You can, in theory, apply AI agents to any enterprise process that humans do manually today.
Any process. That's huge.
It's a staggering thought, yeah. We could literally agentify almost everything.
So what kind of processes are we talking about?
Well, think about customer service desks handling really complex problems, or industrial processes like, say, optimizing HVAC systems in a huge building for energy efficiency.
Okay, practical stuff.
Or even using agents to help build the underlying tech itself, the software, the data pipelines, the ML engineering work that creates more AI.
Agents, building agents.
Potentially, yes. The scope is just incredibly broad. It suggests a really fundamental shift in how businesses might operate.
So if we can agentify almost anything, what's the biggest change you see coming from this in, say, the next 5 years, beyond just making things faster?
That's a great question. Efficiency is definitely a big driver, yeah. But maybe the biggest change will be enabling completely new business models.
New models, like what?
Services that were just impossible before because human limitations were the bottleneck. Imagine hyper-personalized services delivered instantly at massive scale. Or supply chains that adapt in real time to, say, a sudden global event without needing constant human fiddling.
Okay, so building truly adaptive, almost intelligent operations.
Exactly. That's the potential.
But it's not just about taking a human process and, like, making a digital copy, is it?
No, absolutely not. That's a key point. When you're agentifying, there are principles to follow. First is that efficiency mindset.
Right, Biswas stresses that you shouldn't just map manual processes one-to-one onto agentic ones. Why not?
Because an agent isn't like a human. It's not bound by HR rules or office hours or, needing coffee breaks.
Ah, right. No coffee breaks for the AI.
Exactly. A software agent can work differently, much more efficiently. So you need to design the process to leverage that, not just mimic the old way.
So it's a fundamental rethink, not just a copy-paste.
Precisely. And the second principle, which is critically important, security and governance.
Yeah, you mentioned that. Designing them with utmost care.
Utmost care. This is where it gets really serious. The article points out that humans are often the weakest link in security, right?
Unfortunately, yes.
Well, with agents, a single agent can break the whole execution. Just one mistake, one vulnerability.
Oof. So if an autonomous agent goes rogue, messes something up badly, who's responsible?
That's the million-dollar question, isn't it? Whom do you blame?
Hmm.
Fine, fire. You can't fire an agent.
Not in the usual sense, no.
So this just underlines why you absolutely need robust logging, observability, seeing what it's doing, and strong, responsible AI guardrails built in from the very start. You need transparency, you need accountability.
Okay, those principles make sense. Efficiency mindset, strong governance. So how do you actually build one of these things? The article talks about a 5-stage life cycle.
Right. Stage one is use case definition. Pretty straightforward, but vital.
Define the problem.
Exactly. Clearly define the problem you're trying to solve. Understand the business context, figure out what data you need, what data you have.
And set clear goals, right?
Yeah.
Quantifiable ones.
Yes, quantifiable objectives,
No?
including, importantly, estimating the return on investment, the ROI. You need to know what success looks like before you even start coding.
Makes sense. Okay, so we've found the perfect problem to agentify. What's next? Stage 2.
Stage two is setting up the agent and tool marketplace.
A marketplace. Like an app store for agents.
Kind of, yeah. The article makes a strong point that trying to define agents and build all the necessary connections to enterprise tools on the fly, it doesn't really work in practice.
Too messy.
Too messy, too slow, too unreliable. You need a structured place, a marketplace, where you have your reasoning models, your LLMs, pre-approved agents, and the tools they can use.
And how do these agents and tools talk to each other reliably?
That's where specific protocols come in. One is the agent-to-agent protocol, or A2A. It introduces this idea of an agent card.
Like a business card for an AI.
Exactly. It's basically a standardized JSON document. Think digital business card. It has the agent's name, description, who made it its identity,
Okay.
its service endpoint, like his web address, its capabilities, can it stream data, handle push notifications, how to authenticate with it securely, and crucially, its skills. What can it actually do? What inputs does it need? What outputs does it give? Maybe some examples.
So other agents can just look up this card and know how to interact.
Precisely. Client agents use these cards to discover other agents and interact with them securely.
Clever. And there was another protocol, MCP.
Yes, the Model Context Protocol, MCP.
Mm-hmm.
It does a similar job, but for discovering tools dynamically. It uses these special MCP URIs.
Like special web links?
Kind of. They let an agent retrieve detailed metadata about a tool, what it does, how to use its functions. It enables that seamless automated collaboration between agents and the tools they need.
Okay, so these protocols help agents find and use each other and tools.
Right. Although the article does note that currently discovery often relies on natural language descriptions. And it calls for more formal capability, constraints-based discovery models. Meaning moving beyond just reading descriptions towards a more precise, automated way for agents to know exactly what another agent or tool can do based on formal specifications for even more reliable interactions.
Got it. So protocols are key for the marketplace. What's stage 3?
Stage 3 is agentic logic design. This is where you map out how the agent will actually achieve its goal. And there's a really key difference here in approaches.
Right.
You can have deterministic agents or autonomous agents.
Deterministic versus autonomous, what's the difference?
Deterministic agents follow a predefined plan, a static orchestration schema. They use a fixed set of agents and tools in a mostly predetermined sequence. It's like following a very specific recipe.
Predictable.
Predictable, yes. Now, autonomous agents are different. For them, you might only specify the high-level goal, like increase sales by 10%.
Just the goal.
Just the goal, maybe as a prompt to an LLM. Then a component called the planner dynamically figures out the steps. It defines the execution plan.
And it can change the plan.
That's the crucial part. It can adapt the plan during execution. It reacts to what's happening based on observations it stores in its memory. It's much more flexible, more, well, autonomous.
That dynamic adaptation seems like the real game changer. It can handle curveballs.
Absolutely. It's what makes them truly powerful for complex, unpredictable environments.
Okay, so that's logic design. Stage 4 is inferencing optimization. Sounds technical.
It is a bit. We've heard a lot about optimizing LLMs themselves, right?
Yeah.
Making them smaller, faster, like SLMs, smaller language models.
Yeah, for efficiency.
Right. And while that's been a huge focus, optimizing the agents for running efficiently, for inferencing, hasn't maybe had quite the same spotlight yet, especially as they move into enterprise workflows.
But it's becoming important now.
The article predicts it definitely will. It says cost optimization and power efficiency will come back into focus as soon as we have more agents in production. Think about running lots of these agents constantly.
The cost could add up.
Exactly. And it also includes making them efficient enough to run on edge devices closer to where data is actually being generated or action needs to happen, not always in the cloud.
Okay, optimizing for cost and location. Makes sense. And the final stage, stage 5.
Stage 5, the governance layer.
Hmm.
We touched on this, but the article's crystal clear here.
Non-negotiable, you said.
Absolutely. Biswas writes, quote, "Without this layer, no agent is going into production in any enterprise, nor should they actually be allowed to do so." End quote.
Strong words.
And it's not just academic. He mentions real-world examples, like a widely circulated letter from JP Morgan's CISO, their Chief Information Security Officer, stressing the need for secure, resilient agentic setups. Even OpenAI's own agent SDK shows this industry focus.
So what does this governance layer actually involve?
Things like end-to-end observability, really knowing what the agent did step by step. This is crucial for figuring out what went wrong if an agent gets stuck.
Or goes off track.
Exactly. You need rollback strategies for scenarios where the agent starts going off script, ways to undo or correct its actions safely.
So the big takeaway for listeners here is,
The takeaway is that building reliable, trusted agents that you can actually deploy in a real business involves way more than just, writing a few lines of Python code. It's a serious engineering challenge with multiple layers.
right, it's complex. So how do all these stages and layers actually fit together? The article shows an agentic AI reference architecture, like a blueprint.
Exactly. A blueprint for these systems. It lays out the core components.
Okay, what are they?
There's the agents and tools marketplace we talked about. Then a planner or reasoning layer that's like the brain. A personalization layer. An orchestration layer to manage the workflow.
The governance layer must be in there too.
Definitely. An observability layer, handling the logging, checkpointing, all that governance stuff. An integration layer to connect to existing company systems. And finally, a shared memory layer, both long-term and short-term memory.
Okay, let's unpack a couple of those. The planner and reasoning layer, that's where the LLM figures things out.
That's right. An LLM takes the high-level task you give it and breaks it down into smaller, manageable steps.
The article had a great example of this, didn't it?
It did. The prompt was something like, generate a tailored email campaign to achieve sales of USD 1 million in 1 month. Very. And the LLM might initially decompose that into steps like analyze products, identify target audience, create tailored email campaign. Pretty logical first steps.
But then it adapted.
Yes. This is the cool part, the autonomous adaptation in action. The agent doesn't just follow that initial plan blindly. It watches how things are going.
Monitors results.
Exactly.
Mhm.
And an example, if it saw it wasn't on track to hit that $1 million goal, it autonomously added new tasks to its own plan.
Like what?
Things like find alternative products to promote, or utilize customer data to personalize the emails more effectively, or perform A/B testing on different email versions. It dynamically adjusts its strategy.
That's really powerful, that adaptation.
It's a key feature of autonomous agents.
And that ability to adapt kind of leads into the need for a personalization layer.
It does. Just like we fine-tune LLMs to be good at specific things, like medical diagnosis or legal writing.
You need to fine-tune agents too.
Exactly. You need to customize or fine-tune these potentially generic AI agents so they understand your specific business context, your user personas, your unique use cases, making a general tool highly specialized.
Okay. And then there's the integration layer. This sounds crucial for actually using agents in a real company.
Absolutely essential, because these agents don't operate in a vacuum. This layer handles orchestrating maybe multiple agents working together.
And talking to existing systems.
Yes, it supports different ways they interact. Agent-to-agent calls via APIs, an agent providing output for a human user, a human kicking off an agent's task.
Or even agents working together but with a human keeping an eye on things.
Right, human-in-the-loop scenarios. And critically, it ensures seamless connection with existing enterprise systems, your CRM, your ERP, whatever, often using that MCP protocol we mentioned earlier to understand how to talk to those systems.
Got it. And the last piece of the architecture, the shared memory layer. Why is memory so important here?
Well, think about those complex tasks again. They can be really long-running. The article uses that email campaign example, monitoring it for a whole month.
Right. An agent needs to remember what happened yesterday or last week.
Precisely. Memory management is key. It's about sharing context between different subtasks and maintaining the overall execution context over potentially long periods.
So how does it work technically? How does an AI remember?
The common approach involves saving information agent status, observations, decisions as embeddings. Think of embeddings as like numerical representations of concepts or data points.
Numbers instead of words.
Sort of. And these embeddings are stored in a special kind of database called a vector store. This database is really good at finding similar embeddings very quickly.
Like finding related memories.
Exactly. It often uses algorithms like approximate nearest neighbors or ANN for super fast retrieval. So the agent can instantly recall the most relevant bits of past information, even from a huge amount of stored memory.
So it has both short-term working memory and long-term recall.
That's the idea. The architecture includes both short-term and long-term memory modules, so the agent has what it needs, both for immediate tasks and for remembering history over extended periods.
Okay, that architecture makes sense. Marketplace, planner, personalization, orchestration, observability, integration, memory. Lots of moving parts.
It's definitely a comprehensive system.
So we've covered the what and the how. Let's look at agentification in action. But the article had a couple of case studies, right?
It did. And the theme is really about re-engineering existing manual processes to get more efficiency and better, more personalized results.
Driving real business value.
Exactly.
What was the first case study?
The customer service desk. Think about how that works now. Human agents often follow a script or a knowledge-based article, an SOP standard operating procedure.
Yes, step-by-step instructions for common problems.
Right. Predefined process, step-by-step for recurring issues.
So how does agentic AI change that?
Well, you bring in LLMs, but you augment them with tools, scripts, APIs, maybe a user interface component. They automate the steps involving interacting with the user and interacting with back-end data systems.
So the LLM asks the questions.
Yeah, the LLM can generate the questions, interpret what the user types or says, extract the key information, and generate status updates or acknowledgments back to the user.
And the tools handle the data fetching.
Right. APIs pull data from different systems. Then, a reasoning LLM uses that data to make decisions about the next step. The article has this neat idea of thinking of a knowledge base article as a DAG, a directed acyclic graph.
Like a flowchart.
Basically, yeah, a complex flowchart or decision tree. Each node is an action with an ID, a type, some metadata, and the LLM-based agents can just autonomously execute the steps in that flow.
Wow, so you could have a whole team of specialized agents working on one customer issue.
That's the concept. The article lists several: a customer agent, product agent, SLA agent for tracking service level agreements, personalization agent, responsible AI agent, the guardrails, maybe an audio agent for voice calls, a RAG agent, retrieval augmented generation. That helps the agent pull in external, up-to-date info from the knowledge base as needed, and maybe even a specific agent just for generating polite email responses.
A whole digital team working together.
Exactly. An ecosystem of intelligence focused on solving the customer's problem efficiently and effectively.
Okay, that's customer service. What was the second case study?
The second one focused on data management and data engineering, core back office stuff.
Like data cataloging and warehousing?
Precisely.
Yeah.
Applying agentic AI to those fundamental processes.
And what are the key tasks agents could do there?
Things like automating data pipelines, ingestion, modeling, transformation, making governance and compliance happen automatically using AI-driven policy enforcement.
Taking the manual work out of compliance, that's huge.
Huge. And also enabling faster insights and predictions from the data for better business decisions in real time.
So what kind of agents would you need for, say, data cataloging?
The article lists a few: a supervisor agent to watch for new data sources, a data discovery agent to automatically figure out what's in the data, extract entities, enrich the metadata.
Making the data understandable.
Right. A data integration agent to connect smoothly with things like ERP or CRM systems, a metadata validation agent to check for consistency, and a data observability agent to track data lineage where it came from, how it changed, and ensure compliance.
And for the data engineering side, like building warehouses.
Similar structure. A supervisor agent scheduling the jobs, ETL agents extract, transform, load to automate the entire data pipeline.
Automating ETL sounds like a dream for data engineering.
Oh, absolutely. Then a data quality agent checking data integrity, a data modeling and tuning agent that could maybe even dynamically adjust database schemas for performance. And again, a data observability agent, this time monitoring warehouse performance and maybe even auto-tuning the pipelines.
So again, a whole suite of agents managing the entire data lifecycle.
Exactly. It's comprehensive, touching everything from data creation and processing to making sure it's high quality, compliant, and usable.
It's fascinating how this whole agentification idea really seems to, well, reimagine these fundamentally manual
It
processes,
really does.
transforming them into these highly automated, hopefully more personalized workflows. It definitely feels like a powerful new paradigm.
It has the potential to disrupt a lot of traditional business processes, for sure.
Moving from static software applications to these dynamic, autonomous things that can intelligently do complex work.
It's a significant evolution, no doubt about it,
Yep.
in how AI works with and really drives business operations.
So, thinking about all this, what does it all mean for you listening right now? Maybe think about your own work or your industry.
Mm.
Where are those manual, maybe tedious processes that could be re engineered, reimagined,
Mhm.
potentially transformed by these autonomous AI agents?
Could it free you up? Allow you to focus on more strategic work, more creative problems, while the agents handle the repetitive stuff?
It's definitely something to consider,
And it raises a really interesting question for the future, too, doesn't it?
which is
Well, if these agents can adapt on their own and run complex tasks for long periods, how much human oversight is actually going to be enough?
enough to ensure safety, make sure they achieve what we want beyond the governance layers we talked about.
Right. How might this fundamental shift from static programs to dynamic autonomous agents,
Mhm.
how might that really change the very nature of work itself?
That's a big thought to end on. Lots to mull over there.